Hello, so let us start with few problems in today's class. So the problem is to find the angle between the pair of lines. So first we have x square plus 2hxy minus y square equal to 0. So here a is equal to 1 and b is equal to minus 1. So therefore theta is given by tan inverse of 2 root of h square minus ab by a plus b varum. So that will be equal to tan inverse of 2 root of h square plus 1 by, so this is 0, so we will get tan inverse of infinity, so which is equal to pi by 2. So the angle between the pair of lines is pi by 2. Next we have 4x square minus 24xy minus 11y square equal to 0. So here a is equal to 4, b is equal to 11 and h is equal to 12. So theta will be tan inverse of 2 root of h square minus ab by a plus b varum. So that will be tan inverse of 2. So you'll get 144 minus AB will be 44 by A plus B is 15. So you will get tan inverse of 2 into root of 100 will come. So 10 by 15. So that will be tan inverse of 4 by 3. So that's the required value. And next we have x square plus 2xy cosec alpha plus y square equal to 0. So here you have a equal to 1 and b equal to 1. Then you have 2hxy. So h is going to be cosec alpha. So therefore theta will be tan inverse of 2 root of h square minus ab by a plus b. So that will be tan inverse of 2 by 2 varum root of h square. So that will be cosec square alpha minus 1. So that will be equal to tan inverse of root of cosec square alpha minus 1. So which is equal to, so that is tan inverse of, so you'll get root of cot square alpha. So that is equal to tan inverse of cot alpha. So that is tan inverse of, this is tan pi by 2 minus alpha. So you'll be getting pi by 2 minus alpha. So that is going to be the angle between the pair of lines. And now we will look at the general equation of the second degree. Appa nammal different conics kandu, then we have seen what is parabola, ellipse and hyperbola. Then we have seen the pair of straight lines. So these are all equations which are of second degree. Now let us now take a general equation of second degree and let us see for the conditions when it becomes a conic or a pair of straight lines. So general equation of second degree can either represent a pair of straight lines, parabola, ellipse or hyperbola. So we look at what are the conditions for such a representation. And okay, so the general equation of second degree in x and y is of the form, so that is of the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So the curve represented by this equation is usually called as a conic section or simply a conic. The curve is also called as a second order curve. So let us write that. So the curve represented by this equation is a conic section or simply a conic. നമ്മൾ ഏറ്റവും ആദ്യം കോണിക് സെക്ഷൻ എന്താണെന്ന് ഡിഫൈൻ ചെയ്തു. നമുക്കൊരു ഡബിൾ നാപ്ഡ് കോൺ ഉണ്ടെങ്കിൽ അതിന്റെ പല ക്രോസ് സെക്ഷൻസ് എടുക്കുക. അപ്പോൾ പല ക്രോസ് സെക്ഷൻസ് എടുക്കുമ്പോൾ you can get either a parabola from it, then you can get ellipse from it, you can get hyperbola from it, or you can get a pair of straight lines. So these are collectively called the conic section. So when you take a general second degree equation, so all this category of curves can be represented using this second degree equation. So that's why this equation represents the curve called conic section or conic. So the curve is also called a second order curve. Now let us look at the different classification of this curve. So for this we need three quantities. So the nature of the conic is determined by the quantities. So first is we represent it as delta. So that is the determinant A, H, G, and then you have H, B, F, and G, F, C. And D is AB minus H square and P equal to A plus B. And now let us look at when do we get the different conic sections. So if delta is equal to 0, so delta is this determinant. So if delta equal to 0, then we'll just call it as equation 1. So if delta equal to 0, equation 1 represents a pair of straight lines. And again, the second classification is if you have A equal to B and H equal to 0, the equation represents a circle. And the third classification is, so if delta not equal to 0, the equation represents a proper conic. So the equation represents a proper conic. That means it is either a parabola, ellipse, or hyperbola. So here D determines the nature of the conic. So when delta is not equal to 0, you are going to get a proper conic, and the nature of the conic depends on the value of D. So let us look the three cases. So when D is equal to 0, so that is when AB is equal to H square, the conic is a parabola. and in this case the second degree terms will form a perfect square. So in this case the second degree terms form a perfect square. And the second case is when d is greater than 0. So when d is greater than 0, we have AB greater than h square. Then in this case, the conic is an ellipse. And the third case is when d is less than 0. So when d is less than 0, we will have AB less than h square. Then in this case, the conic is a hyperbola. And again, the special case of this is if you have a plus b equal to 0, the conic becomes same conditions. You must have d less than 0 and provided you have a plus b equal to 0. So the conic is a rectangular hyperbola in that case. So the conic is a rectangular hyperbola. Let us look at an example. So discuss the nature of the conic. Represented by 3x square minus 8xy minus 3y square plus 10x minus 13y plus 8 equal to 0. So here we have a equal to 3h. So okay, let us write the general form. So that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So let us now write the determinant delta. So delta is, so the diagonal entries will be a, b, c, and here you will have h, h, then you will have g, g, and here you will have f. Okay, so you will have determinant. Now a is equal to 3, so h is going to be equal to minus 4. So minus 4 വരും. ഇനി b യുടെ value minus 3, c value is 8. ഇനി നമുക്ക് വേണ്ട എന്താ 2g, so g is going to be 5. So we will have 5 here. Okay, we write it here. And now you need f. So f is going to be minus 13 by 2. So you will get minus 13 by 2. So this is going to be the value of delta. So find out the determinant. So when you find the determinant, you are going to get it as 33 by 4. So which is not equal to 0. So therefore delta is not equal to 0. When delta is not equal to 0, it will represent a proper conic. Now let us find the value of d. So d is ab minus h square. So a is 3, b is minus 3, and h is minus 4. So minus 4 square. So that is minus 9 minus 16. So which is minus 25. That is less than 0. So when d less than 0, so you have delta not equal to 0 and d less than or equal to 0. So therefore it is a hyperbola. Specifically you can look for whether it is a rectangular hyperbola. So when you take a plus b equal to, so a plus b will be here 3 minus 3, which is equal to 0. So okay, so therefore it will be a rectangular hyperbola. So therefore it is a rectangular hyperbola. So that is the